So we're gonna do expansion and contraction. And we're gonna go through a few examples as we go along. So the first example is the classic ball and this hoop. So general thing is this. If you have liquids and gases and solids, if you heat them up, they're going to expand. Okay? And if you cool them down, they are going to contract. So we're using a solid here to show you what happens. And we're just heating that ball in the flame. Now what happens when you heat it up in a solid, you give more kinetic energy to the particles, they move around and they get slightly further apart. That means the whole thing will get slightly bigger and it won't fit in the hole anymore. Okay, so let's look at another application of this, which is thermometers. The liquid expands when you heat it up, which means it forces the liquid up the tube, and that reads the thermometer. This is your example which doesn't fit the general theme. The general theme is you heat it up, it expands. Now, with water, if you cool it down, it expands, and if it turns to ice, it will expand and it will split the pipe. Okay, and that's why central heating has to be on in very cold countries all the time, so that the liquid within the central heating doesn't freeze and doesn't burst the pipes. Now, if solids, liquids and gases are heated, their volume will increase slightly, and we call that thermal expansion. And obviously the converse, if you cool it, it will contract and the volume will be less. Now, normally it's very small, but it can buckle railways and things like that. So sometimes the questions are based upon why is there a gap between the railway lines? There's a little gap between the metal railway lines because if it expands, it doesn't buckle and do this. Okay. Now, next thing, liquids expand as well. We use those in thermometers. Okay. And gases expand a lot when they're heated, and you can see that in explosions and things like that. That's why you get big explosions, because the heat causes the gases to massively expand. Now, this is part of kinetic theory. Kinetic theory means increased vibration. It's to do with vibration of the atoms, and you get increased vibration when you heat something up. Okay. Now, if that's the case, the opposite happens when it's cooled. The vibration goes down and the material contracts. So let's look at this in terms of a picture which you might want to draw if you're ever asked. Okay, so here is your 6 particles. And then we're going to heat it up and give it lots of kinetic energy. It's going to move, and it hits each other and it gets a little bit further away. And it ends up looking like this. The bigger gaps between the particles, very good thing to say, because the increased kinetic energy, okay, and then that gives you this larger volume you can see. Let's have a look at some applications of expansion and contraction of solids, liquids and gases. So it can be used in building and engineering projects, okay, and it can also be used in the home. So if you look here, there's our example we've already used, which is the thermometer. Remember, the liquid expands, okay, forces it up the narrow tube, and that small volume change will give a big change in length. You need to calibrate the thermometer. So for example, put on the thermometer where 20 degrees is, put it in a 20-degree room, and then make sure you mark 20 degrees on that thermometer. It's a way of calibrating them. Sometimes you do experiments in classes where you have thermometers without any markings on, and you have to calibrate them. Right, next one. We are going to go for bimetallic strips. Now, nowadays can be slightly different, but they definitely used to use bimetallic strips where it's 2 metals that expand at slightly different rates, so different thermal expansion. So if you can see here, try and think which one of these expands more. Well, it looks to me like the gold-looking one, which is the brass, okay, is expanding more than the silver-looking one, which is the invar. That makes the whole thing bend, and they can use that in control of heating systems and things like that. Now, the last example we're going to talk about thermal expansion is what's known as the anomaly, and this is to do with water and ice. So it's a slightly complicated diagram, but water has little minuses and little pluses all the way through it. And when it flows over each other, those little minuses and pluses all attract to each other. And they brings the molecules together. It's something called hydrogen bonding. You don't need to know it at this level, but basically it just pulls, all you need to know is that it pulls those water molecules together when they're in a liquid. Now that's liquid water. Now if you have solid water, which is ice, those attractions are fixed in position, and you have something called an open lattice. But basically it means stretched out, it's bigger space again, so the whole thing expands, okay? So why does it have a low density? So density, let's talk about density as well. If they relate it to density, density is how close the particles are together. So you can see the particles here are closer together and they're further apart here. So this one has a lower density. So if there's bigger distance between the particles, it's lower density. This has a low density. Now, it is a bit strange. Okay, when it's cooled, okay, it should contract as expected. Okay, however, when it freezes, it actually should get small, but it doesn't. It gets bigger. And that's because the space in between the particles is larger. And they arrange in this open lattice structure, and it spaces them all out, and the ice is therefore less dense, and therefore it floats in water. So what would that be if it floated on water? Well, what it would be is this. Liquid water is like this, okay? And then solid water is like this. It's a beautiful picture. And that's an iceberg. And that's why icebergs float on top of water. That's why your ice floats in your drink. It's because it forces the water molecules apart, bigger distance, lower density, and there you have it. And this is your video on expansion and contraction.